Okay, so this is an example. We're doing overcoming friction problems from the homework, and we did this one in class. This is number 1. Let me add that here. This is problem number 1. And this is on page 141. Let's add that. Okay. Now, somebody had asked about problem number 2, and I kind of want to show you how to do that. But if you remember, problem number 2, or if you look in the book, it requires the information from this problem to solve the problem on number 2. So if we give ourselves a new page and use the information that we figured out in the first problem, it says we have the same conditions where 185 newtons applied, and the box has the same mass. So if we did the mass, it's 35. Let's undo that. 35.0, and then the U of K is 0.27. Okay, but the only difference is it's on a 12-degree incline. So if we were going to show that on as it actually exists, let's go ahead and do that. And then I can show you how to take what we know from the other problem and solve it, plug it into this one, and then solve for the correct answer. Okay, so what we really have is that same thing from the last problem. But instead of being on a square, it's 185 newtons, 25 degrees, and the only difference is this has a 12-degree angle. Okay, and in our last problem we calculated what each one of these would be for the 25 degree. I think we came up with 168 newtons, and then we came up with 72. Let's go back and look here real quick. $78.2. So if we plug that in, stop, 78.2 newtons. So if we resolve this out, this is now gone, and we know we're 168 and 78.2. Okay. So the only thing we need to figure out is how do we resolve for that angle. So if we then, and we know also we want to remember this here, we have the force of gravity, and then we always have this force of friction here. And so we start off with this premise of what we figured out from last time. Now we can't use the acceleration and those kind of things and the normal force really, because this angle is going to change it a little bit. So what we really want to do is take this and remove this 12-degree angle. So we would rewrite the block. Okay, this is still 168. This is still 78.2. And these, if you remember, we go to black now. This is force applied X, and this is force applied Y. The only difference we now have is this force of gravity is 12 degrees. Has been moved by 12 degrees to make up for that 12 degrees that's been lifted. So, and you remember force of gravity is mass times acceleration. So really what we need to do now is to figure out this thing right here, this force of gravity X, and then this would be the force of gravity Y. How we do that is just the same way we figured out these top angles here. We would use SO and Ka. And we know, we just need to figure out what is this force right here. Force of gravity, that's mass 35 times acceleration 9.81. If we go back to the original problem that we did, it told us that that was, where is it, 343. So let's put that in. So this is really 343. Okay, and then so then we're going to use that. That 343 is actually this one here, and the 12 degrees just comes in when we lower this box to a level surface, and then when we move it 12 degrees that way, then we have this 12-degree angle here. So then we know it's going to be 343 times the cosine of 12 and 343 times the sine of 12. So then we do the math. That one gives us 336. Okay. This one gives us 71.3. And sine is going to be the opposite. And this one's going to be cosine, the adjacent. Opposite, adjacent. Okay. So we then look at this. Here's the angle. The one that's touching it is the adjacent. Okay, so that's going to be your 336. That's going to be one that's opposing the normal force. And then force of gravity X is going to be the opposite, which we'd have this one here, and then we'd have this one across here, but really it's this one up here. So then this would be 71.3 newtons. Okay. So then we have some numbers to work with. We can kind of erase this and move this back up to where we are, to that spot. See if we can get that figured out. Yeah. So if we go up that way. So now we got that up there. And we now can figure out a few important things. I'm going to erase this stuff too. So now we can do this thing. The force net X is all the forces acting on the X is equal to the mass times the acceleration on the X. Okay, so how, if it's tilted, how's that going to affect the acceleration really? This 12 degrees, how's that going to affect it? And we know the force net X is the force applied X minus the force of friction, and that's mass times acceleration X. We know what this is. It's 168. It's going to be minus force of friction, if you remember the equation. The force of friction is the U of K times the normal force. So we know that's going to be minus 0.27. And then it's going to be, then it's going to be the normal force, F of N. Then we'll come back because we're going to add something to this, and then mass acceleration X. Okay, because actually when we have this on an incline, we're not only going to have this force here as well, the force of friction, but we also have this other force that's added due to gravity. So we'll figure out this one, then we'll add the other one at the end. So then we have to figure out the normal force. To figure out the normal force, we have to realize that it's opposing, it's opposite that force. The normal force is a force that acts opposite of gravity, the force of gravity. So the force of gravity on the Y is 336. So if we want to figure the force net Y, that's equal to the force of gravity Y minus the normal force plus the force of gravity X. So we have all that. So we know what this is, 336, minus, we don't know what the normal force is, we have to figure it out. But we know there's an additional force, 78.2. Okay, so then if we minus 78.2 from both of them, this cancels, and then we get 336 minus 78.2, we get 258 we'll go with. and that equals the normal force. So now we have this. We can keep going. 168 minus 0.27 times 258, and then we have to add the force from gravity, which is 71.3. So then let's do that now. Let's do the math of this. 0.27 times 258, that gives us 69.66. We'll just make it 70 plus 71.3. That's going to give us 141.3. So it's going to be 168 minus 141.3. The final answer, 68 minus 141.3. That gives us 26.7. That's the force of friction. Or that's the actual force on the x, because we did this is your force applied x, and then we minus these two forces, which are the force of friction and then the force due to gravity. So we end up with a total force x, force net x, is 26.7. So then we plug that in. Let's just rewrite it. We figured this out for that. So we get 26.7 equals 35 times A. Divide both sides by 35, and we will get acceleration equal to 0.76 meters per second squared. And that should be the correct answer. And that's how you solve that one, by using the original problem number 1, and that's good.